Hello, hope you guys can hear me. Let me just set up my chat. Also, I'm going to be studying Calculus 2 this time. I finished Calculus Volume 1 yesterday, but I did not fully do the last chapter, which was about the hyperbolic trigonometric functions. I think I will leave that specific chapter for later. Okay, let me switch to full screen. Okay, so Calculus Volume 2. We did integration in Volume 1 and applications of integration in Volume 2, except for the last part, Calculus of hyperbolic functions. We will start with techniques of integration. But before I start that, I just want to write down what I understood so far but about the hyperbolic functions. I still need more practice with that, but I'll just write down what I understood. So every function can be broken down into its even part and an odd part. So an even function is uh, I don't know why this. Okay. So an even function is like x square, where this right side and is a reflection of the left side, and x cubed, this is an odd function, and if you rotate it 180 degrees you still get the same graph. So when this positive side is equal to the negative of the negative x side. So if I do this, if I do a minus, if this is a minus and the y value is also minus, you get the same graph back. That's the odd. Also can write it like this. Even function, for any function, the even function can be written like this. So I have f of a plus the negative part this plus the negative part would give the even function. I will tell you later why I'm dividing it by 2. F of a minus this to give you the odd part. Now, why did I divide it by 2? If you add them together, you will get f of a back. If you add them together, this f of minus a, f of minus a, these two will cancel out. Then you are left with 2f of a, and the 2's will cancel out. So basically that's why I wrote it like that. So if I have f of x, well, this is already an odd function. maybe another function like ln of x, maybe. Yes, this is neither even or odd. Let's do ln of x plus 5 ln of x. Right, we have this function over here. If we do f of x plus the negative, we get this even function. And then if we do minus, we get an odd function. This will work for any f of x. For any function, we can separate the even and odd like this. Of course, I'm dividing it by 2 because if you add them back together, you get f of a back. So now how is this relevant to hyperbolic functions? If a unit hyperbola, a hyperbola is any graph that's written like this: a minus y square over b equals 1. So a hyperbola is any graph that's written in this form. And so if I increase b, then I can change this. And if I remove this here is a unit hyperbola. So unit hyperbola is x squared minus y squared gives you 1. Now if I square the even and odd parts, square, this would give me I'm going to f of a squared, so this multiplied by this itself, plus 2 f of a, f of minus a, then plus squared, all this over 4. And for the f of odd, I square this, I get this same thing. Whoops. I get, yeah, wait. Sorry, if I take all of this, except that this is a negative. Now, if I subtract these two, this and this cancels out, this and this cancels out, this minus becomes plus, so I have 4 f a f minus a, and then this 4 also cancels out. Now if f of a is equal to some constant b to the power of a, then this here becomes 1, right? Because b to the power of a times b to the power of minus a, those two cancel out and becomes 1. So 1 is equal to this, of course. So that means I can use these two as a hyperbolic formula, as a unit hyperbola. So x is even part, so x is f of e a, and then y is then if I square it and then x squared minus y squared, it will give me a unit hyperbola. So let's try this. F of a is some constant a to the power of b, right? But I don't want to plot this. I get the point. And then we have, let's say, the even part is equal to b to the power of a plus b to the power of minus a, right? And then we got the odd part. I don't want to plot these two. Now f even a squared plus it with f odd a squared. Now this is a parametric equation, but I did not add a slider for a. Now wait. Can I do like x is equal to f of o and then y is equal to, hold on, it's a minus. Yeah, so it should, I think it has some calculation error, but the point is it will always give me a 1 for any value of p. And if I do plot it, let's say x square minus y square equal 1. I can use the even function to define x, and I can use the odd function to define y. So if I plot this on the y-axis and plot this on the x-axis for different values of a, this line will be plotted. So now the trigonometric hyperbolic function is when b is equal to e, and that makes derivating easier. Basically, this will always be 1. I need to check my stream. It says reconnection successful. Hold on. So sin h is the value where the b constant is e. And then tan h is sin h divided by cos h. Let me just check my YouTube stream first and then I'll get back. plot this on the y-axis and plot this. Basically, okay, yeah, so this is 1 now, so that means sin h, already gave the formula. If I plot it, if I plot it on the graph, it looks like this, an even function. And if I plot this on the graph, it looks like this. Sorry, this is an odd function, and then this is an even function. Now, tan h is sin h over cos h. Let's do a, and then this is e to the power of a plus e to the power of minus a. Divide the 2 and 2 cancel out. And then cotangent h is like these two flipped. And then secant, this should be, is I think 1 over cos h, and then cosecant is a 1 over sine. Also, since sin h is like this, the derivative of sin h would be, we can take the half out and then we can derivate them separately. So half e to the power of x stays the same, and then this becomes minus, so e to the power of minus x. If we derivate this with respect to minus x, we get e to the power of minus x, and then if we derivate minus x, we get minus 1. So that's why I wrote minus here. This is cos h x. Then if we derivate cos h, we can take the half out. E to the power of x doesn't change. Minus e to the power of minus x becomes plus e to the power of minus x, because the minus and minus cancel. And then if we derivate tan h, we get low d high. I'm writing cos h like this. Low, d high minus high d low. See, when we choose e when we choose e as the value, it makes derivating it easier. upon bottom squared. And since cos h squared minus sine h squared is 1, we can write this as 1 over, which gives sec h x. I'm not sure. I think this is correct. Yeah, that's how much I will talk about the hyperbolic trig functions. I haven't done any exercises for this, but I think later down the line when I read about, where is it? Yeah, parametric equations, then I will focus more on that. Hold on. I'm just checking the derivative of tan h. Yeah, it is sec h square. This is how much I will talk about it. Now let's go back, start studying techniques of integration. First of all, wait, hold on. Let's go to integration by parts. I might need, this is my website. I might need some calculus equations ready for reference. Anyways, integration by parts. So I know it's integration by parts is like this. U dv is equal to minus u dv. I have used them in the past streams before. Wait. I don't know why this is not loading. But I can't remember the proof. This is VD. By now, we have a fairly thorough procedure for how to evaluate many basic integrals. Okay, let's see if how they did. H of x is f of x g of x. And then what did they do? How did they get this? Derivative of the first times the second plus the first times the derivative of the second. Can write this as also there's one thing I want to ask. Can I just shift the D to the other side? I mean, we have been doing it too with DU. So, mean like this. If I take dx out and put it here, dx out and put it here, get like this. As dg of x dx. If I integrate both sides, this will give me h of x. Let me think about this. Wait, hold on, no, I made a mistake. Should remove these two. And then if I integrate both sides, so adding up with respect to f of x plus z with respect to g of x, this is equal to h of x. Shouldn't there be a plus c here? But I guess if we evaluate this, we will bring out the plus c. I think this is the proof. I don't know if this step is valid where I cancel out the dx, but I think it is. So I can write this in terms of u v v du plus u dv. Use integration by parts. Example 3.1. Integration by parts. Oh, they tell you though. I want like where they don't tell me. Right. Let's try this 3.2. Let's see how I could do this. So if u is ln of x, derivative is 1 over x, if v, I want the derivative of v to be 1 over x squared. So basically, then I can rewrite this as u dv 1 over, no wait, x cubed. So then I can, so v would be 1, no, negative 4 x to the power of minus 4. No, negative 1 over 4, negative 1 over 4. We derive this, wait, let's do negative half. Yeah, so if I multiply this and then subtract 1, I get this, right? So then, hold on. So then this is equal to u times v minus, and then subtract it with the integral v, but since I'm subtracting, I just type plus v times du. So v times du, I get this. This is then no. Yes, I think. Is this the right answer? minus 4x squared. How did they get the minus? Okay, this I got it. This I did not get. Maybe this is minus 2. I guess that would make sense. Also, I used integration by parts in one of my proofs. I think log a to the power of x. Right? Yeah, I used integration by parts here. And then I used it over here as well. Arcsine. Yes, for all of these, I think. Arctan. Yes, and then arcsecant as well. Did I use? Yeah, I used integration by parts. Applying integration by parts more than once. Okay, this is going to be tough. Exercise example 3.3. X square e to the power of 3x dx. If u 3x du is equal to 3x. No, e3x times 3. Now I want dv to be like this. So b. Wouldn't it be easier if it's reversed? Wait. Yeah. So this is u and all of this is v. So if I derivate this, yes, it's correct. So then this is equal to u times v minus it with v times du. This is worse. I don't even know if I'm right. So now if I use integration by parts again, 2 dx. dv is equal to dx. What if I switch these? Should I switch? I don't know if it would be easier if I switch. Never mind. Then v times du. So derivating this give us e and plus c. And is this the correct answer? So I got x squared over 3 e to the power of 3x. Right. So what can I take out? X squared then I'm left with 2x and then plus, because minus the sign switches, and plus c. Imagine if it's wrong. Let's see, 1 over 3. How did 2 over 3 come? So where did I make a mistake? The first term is right. E to the power of 3x over 3 times x squared. This term is right. The last term is 3 times 3 is 9. I'm missing 3 from both of these. I'm missing 1 over 3. So let's see where I made that miss. Oh, 1 over 3, it's here. Nine. Should I do another formula? What is this LEAT? The acronym stands for logarithmic functions, inverse trigonometric functions, algebraic functions, trigonometric functions, and exponential functions. Okay, never mind that. Okay, let's try 3.4. integral t cubed t square, is it t square? Yeah, dt. This remains the same. And then derivative of t square is just t. Then I can put u here. Yeah, right. This makes sense. So and then v times du. I'm worse. Worse. I'm worse off than what I started with. Okay. Let me think. How else? What else can I do? Can switch v and u. D cube. And then dv should be equal to a d square. When you derivate this, et squares remain the same. T square becomes 2t. Right? I made a mistake last time not adding 2. Let me think. T square. I hope this is right. So u times v becomes t square times it by t square over 2. Then subtract it with v times du. T square. Let's do 3 over 2 outside. T dt. Does this work? Put the 3 outside and derivative of this is this. So derivative of half, give me this. So this becomes 3/4 plus c. So then minus instead of 2 I can write 4/4, not minus. Okay, where did I make a mistake? Is this derivation correct? I don't think this derivation is right. So I have to derive this and then like I use the chain rule over here and then I have to derive this separately. Yeah, this is completely wrong. I already saw the answer now. Find the area of the region bounded above by the graph y is equal to tan minus so arctan x and below by the x-axis over the interval. So arctan how should I do this? Hmm. Antiderivative of arctan is this. So let's see. If I do x arctan x minus half, and then if I do 0.438, yes. They did it differently though. Did I? Wait, dx. Yeah, I did the same thing. Find the volume of revolution. Finding the volume of the solid obtained by revolving the region bounded by the curve f of x e to the power of minus x. The x-axis, the y-axis, on the line x is equal to 1. Find the volume obtained by revolving the region bounded by the graph of f of x is equal to, so this x is equal to 1, x-axis, y-axis, and the revolution is around the y-axis. Okay. This is example 3.7. Oops. Um, if I do, right, so let's say I switch these two. This is the inverse function g of x, which is minus ln. Uh, right. If I do y equals 1, we need this, the line x is equal to 1. You need to use the disk method, right, from 0 to 1, but on the y-axis with the inverse. So 0 to 1. I think it's easier if I do y. Never mind, I will just y, y. The revolution about the y-axis. So we want the area of this part on the y-axis. Is the same of asking the area of this part going around the x-axis, right? So I do 0 to 1 by it's not really x, it's more like y. I do, never mind. It's easier to imagine if it's y. Shouldn't it be from 1 to 0? Wait, hold on. X is 0, y is 1, x is 1, y is I'm not sure if I'm doing this right. Shouldn't this be 1 over ex, 1 over e? I think it's easier if I do minus, minus. Am I on the right step? Wait, no, wrong. It's not clear what they're asking. I'll have this going around the y-axis. Oh yeah, canonical conical shells, I think it was called. I have to use that. So the volume is 2 pi f of x. I think 2 pi x f of x. I think it's this. Yes, because it's like opening up one of the shells. So it's revolved around the x-axis from 0 to 1. Now, is this correct? Maybe. Let's see. So dv is x and dx, and this is u. So u times v squared to minus. Hmm. I mean, this did not really help. Okay, how about this? E minus e to the power of x. If I derivate this, e to the power of minus x stays the same, and then derivative of minus x with respect to x is minus 1, and the minus cancels out. This is x squared over 2, and then derivate this, we get this. So no, wait. Starts with u dv. So u times dv, u times is equal to u times v. V minus to the power times it by du. So v times du. Is that right? Integral of e to the power of minus x would just give us this. Is that right? So if I do 2 pi, if I do this, negative 1, this is 1, minus 1, minus 1, e. Is this correct? No, this is not correct. This becomes 1, 1, and 1. So minus 1 over e minus 1 over e gives minus 2 over e. And subtract it with this is 0 and this is 0. E to the power of 0 is 1. So the final answer is 2 pi times this. 2 pi. So this is minus minus becomes plus, right? Okay, I think I will end the stream here. I wanted to do the entire thing, but yes, this is fine. Okay, I will end the stream here. And I guess I'll see you guys next time.